Okay. Hello and welcome to our latest Q&A session. I'm Sadie Moden and I'm talking with Justin Pringle about the benefits of vacuum casting. Before we talk about the benefits though, Justin, could you give us a quick overview of vacuum casting and why it's used in product development?
Hi. Yes, of course. So vacuum casting, it's a process where we use a polyurethane resin material in the production to mold the parts. And how we do that is we use a silicon tool, and the tool is created by encasing a master model. So the master model is the CAD model that we 3D print it, and we prepare the surface finish to the required specification, and then we set this up so we have a feed in for the material to come in, and so it can mold. It's encased in rubber, but before we do that we have to set it up with tape, which is creates a split line around the part, which enables us to cut the master out of the tool, which I'll show in a second. But it's set up and put inside a box, so this master will be in the box, and then we pour in the silicone rubber around that and let that go hard. And once that's gone hard, we take the box apart, and then that leaves us with the tool, which we have here. So the purpose of the tape, as I said, is create the split line, and we put a black line around the edge so we can see it once the master is encased in the rubber. We can then see it, and we use a scalpel blade to cut into the rubber because it's a solid block, and we create serrated marks. So when we start taking it apart, we can then access the master, which will be inside the tool, and then that creates the core and the cavity. And this part here we've got, it shows us that we've got a texture on there, and that will be replicated in the silicone rubber, as you see here. So very quick overview of it. So we create the master, create the mold, and then we cast. And the casting is done in a vacuum chamber. And the reason why that's done in a vacuum chamber, because we remove the air from the liquid resin, and then that is forced into the tool. And when the tool has got all the resin inside it, we then take it out of the vacuum chamber and we put it in a curing oven. And the whole process takes between half an hour and 45 minutes, depending on what material we're running through the part, which would depend on what the customer requirements are. We use vacuum casting as part of the development of a part. Generally, it will be used when the client has gone so far with 3D printing and they need a bit more production intent material. So they're not quite at injection molding yet, because injection molding, the tooling is expensive, the lead times are long, and the design may not be mature enough to go into production. So they use vacuum casting as a go-between while they're verifying the part. They can do some part validation, they can do some testing to then verify their CAD maturity, so they can have confidence to release the designs to a tool maker, which then would make the injection mold tools and then go into production.
Okay, thank you. Let's have a look at some of the benefits then of vacuum casting. What about the choice of material grades? Can you talk us through materials?
Yes, so obviously when an engineer is designing a part, they're considering what that part has to do. So then they're thinking, what materials does this need to do? What we'll use, what environment is it going to be in? So there's a wide range of polymers that the engineer has to choose from. So in vacuum casting, the range of materials is quite narrow because we're only using polyurethane, and then polyurethane is developed to mimic certain types of plastic, and it is a mimic because it's a different polymer characteristics. But we will generally be looking to replicate an ABS or polypropylene or a polycarbonate. And generally the polycarbonate you'll mimic is just the clear polycarbonate, so you want a clear part. So I've got a part here that's been done in clear. So you have a narrower range of materials, but you'll get similar properties. So you can then mimic some of the testing that will be done in your product validation.
Okay. So what about surface finish then? What are the options there?
So as I said, we start off with the 3D printed master model, which will more than likely be made with an SLA printer. And the reason is the material quality is really good. The part definition, so you'll get good features. It's accurate, and the resins that's used in the SLA process are very easy to work with after it's been printed. So we can sand them down, and then we would start building up a paint surface, primer it in a gloss or a satin. Again, that will be down to what the customer wants as their finished item. So we would rub the part down with sandpaper and then primer it and then top coat. And that top coat can be a gloss, a satin, a matte, or we can put a texture into it from from the paint gun, and that can mimic a spark effect, although it's more of it's what's called a spatter effect. And then whatever surface finish we have on the master model will be replicated in the surface of the tool. So then the parts coming off of it will just have the same. So if this part was gloss, your tool would have a shiny surface and the parts would come out glossy. So like here, we have here a part that's been glossed. So this part, the master model, would have been all glossy, and then that tool would have that surface finish.
Okay. So what about consistency then, part to part? Is it controlled or is it variable?
No, so once the tool's been made, the parts will come out consistent to the product run. Now, there is a slight caveat to that, is in the fact that the tool is made of rubber. It's a hot process, as in the A and the B resin mix up. There's a nice exothermic reaction, so there's heat there, and that will attack the tool over a period of time. So generally, the life of a tool is around 20 parts. Okay. But that is dependent on two things: the material you're using in the tool, as in what your part is going to be made of, and also the complexity of the geometry of the part. So if your part is fairly simple, like here, this tool is going to have quite a long lifetime. So you'll get a lot of parts out on it. Whereas if we use a part like this one over here, let me just bring it across, which has a lot of detailed features on the inside, then the small bits of rubber in the silicon tool that are making that will be attacked a lot more. So they'll deteriorate and then become hard and brittle in the tool. And the tool life might be reduced. And then if you add that to a material that, if you've got like a fire retardant material or a material that you need to take high temperatures, they're even more aggressive to the silicon. So there are some materials that we will only get 5 parts out of a tool. So there's the two factors: the geometry of the part and the material we're using. But generally, the parts will be consistent from number 1 to number 5, or number 1 to number 20. They will be consistent. Okay.
So you've talked about finishing options. Are there any other options available?
So yes, we can use some software to put a texture surface on the 3D print, which we have on our sample part here. So we have a part here, and that has been put in before the print. So we put that on the CAD model, and mimic various textures, and we have here a spark effect, like a VDI scale, which is the VDI scale is a scale that is used with injection molding, and it's determining the depth of the spark, which will be used in injection molding. So we can do that. So we've got a different texture on the front face as to the side face, and that's put in using software onto the master model. Okay. And then that will be replicated in the tool.
Okay. Do you have problems with shrinkage in vacuum casting?
So with the process of vacuum casting, you don't generally have shrinkage issues or problems, because the way that the process is worked up, it's all done through heating up the tool and cooling down the tool. So the master models are generally printed 1-to-1.
Yeah.
And then when the tool is heated up in the oven prior to casting, the tool expands, the warm resin goes in, the tool is cured off, and then the tool will cool down. So the shrinkage is linear.
Right.
One of the other things that we don't have to worry about, which you do with injection molding, is wall thicknesses. So with injection molding, you have to be very careful on making sure your wall thicknesses are uniform and smaller than the general thickness of the part. So you won't get shrinkage marks. Mm-hmm. You don't have that with vacuum casting. So it could be that the good thing is that you're developing your part earlier in the product cycle, so you don't have to worry about the maturity of the design to be thinking about wall thicknesses. Yeah. So on an injection molded part, you'd be very conscious of creating these ribs in here, and they'd have to be thinner than the thickness of the part, so you wouldn't get any witnesses. We don't have to worry about that with vacuum casting. So you can have thicker wall thicknesses, and it just creates much easier part to design earlier in the design stage.
Yeah. Okay, you've shown us a few different samples there, varying sizes. What sort of sizes are you able to mold?
So we can mold up to a bounding box size of 450 millimeters by 470 by 400, and a part weight of up to 1.4 kilos.
So moving on then to threaded holes, what are the options there?
So with holes coming in parts, we can put in inserts after it's molded, or we can put them in during the molding process. So that part there has a threaded insert, and that has been molded in.
Okay. What stage of the product development cycle is vacuum casting typically used for?
It will be used at early stages. It depends on what material property. So if somebody's using 3D printing in their early design verification concept work, they may need to do some more testing with a material rather, that's going to be more representative. But generally it will be very early stages, but before pre-production. It can be used for pre-production whilst waiting for injection mold tools to come online, but it will be in early stages of a product development.
Okay, so last question then. So vacuum casting, is it the ultimate prototyping technology?
I would say it's a combination of using the ultimate prototyping technologies, because you're using 3D printing, you're using your master model, and then you're able to get to a representative part of a production intent product. So it's up there with the best.
Yeah. Okay. Thank you. So thank you very much for your time there, Justin. I hope everybody watching has enjoyed it and found it useful. Please come back and we will post some more in the future. Thank you.
Thank you.